Today we're going to be solving some systems of linear equations using a method called elimination. When you're using elimination, you want to multiply, if necessary, one or both of your equations so that you end up with one pair of like terms that has the same or opposite coefficients. Then you can add or subtract the equations to eliminate one of the variables. You can solve the resulting equation so that you will find the answer for one of the variables, and then substitute that value back into one of your original equations so you can find the value of the other variable. So let's see how this actually works. So here's our first example. Our first system is made up of two equations, 3x plus 2y equals 4, and 3x minus 2y equals negative 4. So in this case, we don't have to do any multiplying because I already have a pair of like terms that have opposite coefficients. So I have plus 2y and minus 2y, or positive 2y and negative 2y. And that's what I want to have before I go on to my next step. So I've already accomplished that without doing anything. So I'm going to now rewrite my equations, making sure that vertically my like terms are going to be in line. So my x terms right here, my y terms are going to be second, and lastly here, my constants. And what I'm going to do with these two equations is I'm actually going to add them up. So 3x and 3x gives me 6x. Positive 2y and negative 2y cancel each other out. I have just eliminated one of the variables. And 4 plus negative 4 equals 0. So I'm left with 6x equals 0. I can solve for x by dividing each side by 6, and I get x equals 0. So I've already solved for one of my variables. I already know x equals 0. Now I'm going to take this value and I'm going to substitute it back into one of my original equations. I'm just going to pick the top one there, which was 3x plus 2y equals 4. And instead of x, I'm now going to put in 0. So 3 times 0 plus 2y equals 4. So basically this is 0 plus 2y equals 4, or just 2y equals 4. And to solve for y, I'm going to divide each side by 2, and I get y equals 2. So I have solved and found my solution for this system. It's 0, 2. So let's try another system. Our goal is to have a pair of like terms that have the same or opposite coefficients so we can cancel them out, so we can eliminate them. So in this case, I don't automatically have two like terms with opposite coefficients, but I can make that happen. What I'm actually going to do is I'm going to take this top equation here, and I'm going to multiply everything in this top equation by 2. And you're going to see how that's going to help me in just a moment. So everything in there is going to be multiplied by 2. So I'm going to have negative 20x plus 6y equals 2. For the second equation, I'm not going to change anything. Negative 5x minus 6y equals 23. And now I'm going to add these together. So I get negative 25x. My y terms are eliminated, and I get 25 here. So I have negative 25x equals 25. Or, if I divide by negative 25, I get x equals negative 1. So now that I have the value of x, I can plug that back into one of my original equations to solve for y. So I'm just going to, once again, use the top equation. So my original top equation was negative 10x plus 3y equals 1. So for x, I'm going to plug in negative 1. So negative 10 times negative 1 gives me 10. Now I'm going to solve for y. I'm going to get rid of the 10 first. And I get 3y equals negative 9. And I'll divide by 3. And I get y equals negative 3. So my solution here is negative 1 comma negative 3. All right, let's look at a real life problem. So we have a business. They own 2 different locations. They've bought 7 large delivery vans and 5 small delivery vans, and they have to divvy them up amongst their 2 locations. So location A is getting 5 large vans and 2 small vans, and the cost for that is $235,000. Location B is getting 2 large vans and 3 small vans. Their cost is $160,000. We want to figure out the cost of each type of van. So the first thing I've done is I've assigned a variable to each of the things I'm trying to find. So X is going to be the price for a large van. Y will be the price for a small van. So I want to design some equations here. So location A got 5 large vans and 2 small vans, and their total cost was $235,000. Whereas location B, they received 2 large vans and 3 small vans. And their total cost is $160,000. All right, so we need to eliminate one of these variables. So I'm actually going to do that by multiplying my equations here. I'm going to multiply actually this one by negative 3. And I'm going to multiply everything in this equation by 2. Okay? And I'm going to have to do both here because I don't see any way to just multiply one of the equations and get like terms with the same or opposite coefficients. So let's see what these numbers I've chosen actually do to my equations. So the top one, everything's being multiplied by negative 3. So I get negative 15x minus 6y, and that's going to equal negative $705,000. All right, my second one, I'm going to get 4x plus 6y, and that's going to give me $320,000. So now I'm going to add these equations up. So negative 15 plus 4, I get negative 11x. These variables cancel out. And here I get negative $385,000. So to solve this, I'm going to divide both sides by negative 11. And for my value of x, I end up with an answer of $35,000. So the price for a large van is $35,000. Now I have to substitute back into one of my original equations in order to figure out the value of a small van, what the price of a small van is. So I'm going to use this second equation here. So I'm going to do 2 times 35,000 plus 3y equals 160,000. So this gives me 70,000 plus 3y equals 160,000. So I'm going to have to subtract 70,000 from each side, which will leave me with 3y equals 90,000. And then I can divide each side by 3, which is going to leave me with y equals 30,000. So the price of a small van is $30,000.